Hello there, it's Mr. Neil here. In this video we're going to take a look at the database task from the 2021 Higher Computing Science assignment. By the end of this video you should know what the Higher Computing Science assignment involves, and you should feel more comfortable with undertaking the database task within it. In 2021 the database task was split into two parts. Let's have a look at part A. First we had to start with an analysis task and then do a little bit of design. Here's the context that we're working with. My treat is developing a database of voucher offers from a range of suppliers. Suppliers will offer vouchers in food, beauty, adventure and family. A supplier may have more than one active offer in the database at a time and can sell many vouchers for each offer. Customers registered with My Treat will be able to purchase multiple vouchers. Vouchers will be sent to customers' email addresses. Vouchers will be promoted on the My Treat website, and there we've got an example of the website. So let's look at task 2A. The database development team asked the staff at My Treat how they would like to use the database, and we've got some of the comments from the staff on screen. Using only the information gathered from the My Treat staff comments, identify two functional requirements of the database. So before we start thinking about the functional requirements, we need to understand what functional requirements are in the context of a database. So the functional requirements are what the database must do to meet the end user requirements of the users. So here we have got some comments from the user. So the way I approach this is before I think about the functional requirements, well, what is it the end user wants to do with the database? Pause the video now and see if you can identify some of the end user requirements for this database. Each member of staff has a different end user requirement that they want the database to perform. And from these end user requirements, we can develop a functional requirement. So we want a query to calculate a customer's total spend as per this first user. We want a query to count how many vouchers have been sold by a specific supplier. We would like a query that looks for the offers within a specific category. We want a query that shows the best and the worst sellers. And then lastly, we want queries that allow us to insert, update and delete data. So there are 5 functional requirements for this database, each one of those functional requirements linking with a different end user requirement. So to gain the marks in task 2A, you've got to identify at least 2 of the functional requirements. Moving now on to task 2B. The following tables have sample data showing the vouchers included in each customer order, the customers who have made orders, and the supplier of each voucher. Use the information from the sample data weave to produce an entity occurrence diagram showing the name of the entities, the sample instances providing in each entity, and the association between those instances. Before we start looking at the entity occurrence diagram, we need to look at the relationship between the different entities that we have. We clearly have a voucher entity, a customer order entity, a customer entity, and a supplier entity. So we can see here that voucher appears twice, so there's a relationship between voucher and supplier, and voucher and customer order. Customer order appears twice, as there's a relationship between customer order and voucher, and customer order and customer. By identifying these relationships, it will help us with our entity occurrence diagram. So we have 4 entities within our database. We now need to determine which entity goes in each of the slots. As voucher has a relationship with customer order, those 2 entities have to be in the middle of the table as they have to be next to each other. We can then provide customer and supplier on the peripherals of those. So I'm going to put my entities in the order of supplier, voucher, customer order and customer. Now for each entity, we need to define the instances within that entity. So if we look at supplier, we have got supplier 1, supplier 2, and supplier 3. If we look at voucher in either location, we have got voucher 1, voucher 2, voucher 3, voucher 4, and voucher 5. Can you identify the instances for the customer and customer order table? Here are the instances for the customer order and customer table. The last step of an entity occurrence diagram is showing the relationship between the instances in each of the entity. So if we look at the relationship between voucher and supplier, voucher 1 is matched up with supplier 3, so we draw a line between those two instances. Voucher 2 is matched up with supplier 1, voucher 3 is matched up with supplier 3, voucher 4 and voucher 5 both with supplier 2. Now moving on to the relationship between voucher and customer order. Within this relationship, the customer orders are in numerical order, so I'm going to go from that side of the relationship. Customer 1 matches up with voucher 2, so we draw a line between it. Order 2 goes to voucher 4, order 3 to voucher 5, order 4 to voucher 4, order 5 to voucher 1, and order 6 to voucher 3. And lastly, let's look at the relationship between customer order and customer. Why don't you have a go at drawing the relationship between those instances? The relationship between the instances should look something like this, with customer 1 placing order 1, 3 and 5, customer 2 placing order 4 and 6, and customer 3 placing order 2. And this is a complete entity occurrence diagram which shows us how the instances are related to each other. Now that we've completed part A, we would hand this to our teacher and move on to part B. In part B, we have got 2 SQL implementation tasks, a testing task and an evaluation task. Before we move on to these tasks, we're provided with an entity relationship diagram. This entity relationship diagram shows how the different entities are related and the design that was implemented. At this stage, you may want to open your database management system and look at the tables within it, so you get an idea of what they look like. I'm going to be using SQLite and REPL, so let's go and have a look at our database tables. Here we are within the MyTreats database. I've got 4 queries here, and these are just simple queries that are going to display the contents of each of the tables. If I hit run, we will see the output from it. So we've got a range of customers, and we store their first name, surname, email. We've got a range of orders, and the main information about the order is who bought it, what the voucher was, the quantity and the date that they ordered. For each voucher, we've got some key information about it, the name, the category, the price, when it expires, who supplied it and how many are available. And then for each supplier, we've got who they are and their email address. Now looking at task 2C. MyTreat would like to know how much money has been spent on the different types of escape room vouchers. A query is required to find the customers who've purchased vouchers for an escape room from the adventure category. The output should include the amount of money spent by the customer on the voucher. Implement the SQL statement to produce the following result. Now I could just jump straight into my database and start implementing SQL. But before we get there, I'm going to use the entity relationship diagram to identify the attributes that I'm going to need. So the first thing we're going to need is the first name, and that's in the customer table. We're then going to need the surname, again in the customer table, and we're going to need the voucher ID. Let's get that from the customer order table. Now, in order to calculate the amount of money spent on a voucher, we need to know the price of the voucher. So we'll find that in the voucher table. We know that a customer is able to purchase multiple of a voucher. So we need to know the quantity of vouchers that the customer ordered. And of course the question states that we're interested in escape rooms within the adventure category, so we'll need the category attribute. Now as we're pulling attributes across 3 different tables, we need to think about how these tables are linked together. So we have an equijoin between the customer ID in the customer table and the customer ID in the customer order table. And then we have another equijoin between the voucher ID in the customer order table and the voucher ID in the voucher table. Let's now head over to a database and implement this query. So let's start implementing our query. We've said that we're going to need the first name, the surname, the voucher ID. Whilst we don't want to display the quantity purchased or the quantity available or the category, I'm just going to put it in my initial query to check that everything works. So we're pulling this information from the customer table, from the customer order table, and from the voucher table. So we need to put in our equijoins. Customer.custID equals customer order.custID, and customer order voucher ID equals voucher.voucherID. So if I now go and run this query, we are going to get an error, and it says ambiguous column voucher ID. And this comes from our select line because voucher ID appears in both tables. So we said in our design we were going to use the customer order table. Now if we run that, we can see that we've got for each customer the voucher that they purchased, the quantity they purchased, the price, and the category. We're now going to narrow it down. I only want vouchers that are in the adventure category. So I'm going to add another condition that says category equals adventure. So if we now run this, we only get those that are in the adventure category. So I'm going to take that out of my select. We still have too many people. We should only have 5 people. So let's have a wee read. A query is required to find the customers who have purchased vouchers for an escape room. So let's add in the voucher name and see if that will help us. So escape room for 10, escape room, experience an escape room. Okay, so we need to add so we're going to have to add in a wildcard that will find all voucher names that contain the phrase escape room. So and voucher name like, and we're going to go and put our wildcard in. Now the wildcard symbol that you use will depend on your database. I'm using SQL, so I'm going to use the $sign. Of course, if you're using Microsoft Access, then it's going to be an asterisk escape room. So if we now click run, we get the 5 results that contain an escape room. If we just check, they're the correct people. So we now need to get the field that says amount of money spent on voucher. So we're going to do that by multiplying the quantity purchased by the price. So we'll put a wee asterisk in there. I don't like that name there, so we're going to add a wee alias in. So as, and we'll say amount of money spent on voucher. And if we click run, we now have the 5 people we want along with the correct amounts. So Azia Mossad is 172, Becky Bennett is 344, Shuk Rahib is 86, and the other 2 match as well. So we've got the output that we are expected to get. Moving now on to task 2D. My treat would like to know how many vouchers are still available. Now again, before we branch into our database and start implementing SQL, I'm going to pull up the entity relationship diagram and indicate the attributes that I'm going to need. This is what we're going to need. You can see here that we will require the supplier name as per the design. We will require the voucher ID as per the design and the voucher name. We will also need to know how many of the voucher have been purchased. So we're going to need quantity purchased and quantity available to work out how many are not sold. And then we've got a join between the 2 tables. Voucher ID and voucher ID, supplier code and supplier code. In order to answer this question, we're actually going to need 2 queries. And the clue in the question that tells you we're going to need 2 queries is the fact that it says implement SQL statements. So our first query is going to use an aggregate function to calculate the total number of vouchers that have been purchased. And then our second query will use that number to work out how many are still available. Let's head over to a database to have a look at how this is done. Here we are looking at query 2D. Now, in order to work out the number that are still available, we need to make sure that we know the quantity that have been purchased for each voucher. So I'm going to select the voucher ID and the quantity purchased, and that comes from the customer order table. So there we have each voucher and the quantity purchased of that voucher for each time that it was purchased. Now, of course, we are only interested in one voucher, so let's add a where, and let's see if that gives us the results. So voucher 543 was only purchased twice, and we want to add that up, so we're going to add a sum function to the quantity purchased, and we'll add an alias as total purchase. So if I run that now, we can see that there was 2 purchased. So we now need to save that query so we can use it to do the later calculation. So in Microsoft Access, you would just go and save that query and give it a name. In SQL, we're going to create a view and we will call it a num purchase, and it's going to be as that. So this is a query that's been saved that we're now going to use. So we're now going to write our second query. And in our second query, we want to get the voucher ID, we need the supplier name, we need the voucher name, and we need to work out the still available. So the still available is going to be the quantity available subtracting our total purchase that we have got. So we're going to say total available minus total purchase, and we're going to call that still available. So from our from line, we're pulling customer order, voucher, supplier, and our other query, which is called num purchase. We now need to make sure everything joins up. So in our where line, we are going to make sure that our customer order voucher ID matches our voucher.voucher ID, and we're also going to make sure that our voucher supplier code matches our supplier code. And we've got one other relationship. We've got a relationship with our previous query called num purchase. So we're going to make sure that our voucher ID within one of these tables matches it. So we're going to say customer order dot voucher ID equals num purchase dot voucher ID. Okay, if we now click run, I've used voucher ID ambiguous up here. Okay, so we need to specify where that's coming from. So let's do customer order. We now click run. Sorry, it's not total available, it's quantity. And if we click run, we get a result, but you can see we're getting 2 records here when we only want 1. The reason we're getting 2 records is we know from earlier on that in the customer order table, there are 2 orders for this voucher. So in order to just get 1 output, we need to lastly say we want to group by the customer order dot voucher ID. And there we get the result that we expected. It should be said that this is just one method of implementing this query. There are multiple different ways that you could achieve the same result. Moving now on to task 2E. A query is designed to find the number of customers who brought a voucher from the family category that cost less than £15. We're expecting 4 records to be shown. As you can see, we have been provided with the SQL that was implemented for this query. We are now asked to test the SQL statement by running the query and amending the query to make sure it produces expected output as shown above. Let's head over to REPL and have a go at fixing this query. Here we are with task 2E. I've taken the SQL that we have been given and I've run it, and you can see the results here. And everything matches apart from the number of customers. So a query is designed to find the number of customers who's bought a voucher. So if we've got a number of customers, we're probably wanting to know the number of times a customer appeared in a table. So the number of times that price appeared. So at the moment, we are summing the price. Probably want to change that to count, because that means we're keeping a count of something. So what happens when we run that? 4, 1, 2, 3. So our numbers now match, but it's in the wrong order. What about if we add in an order by line, and we take that number of customers, which is that aggregate there, and we want it in descending order. So there we have it. I've now updated the SQL to make sure it gives the result that we want it to give. The last part of this task is an evaluation task. We are told that the voucher table has no validation. We have to evaluate one potential problem that may occur when adding new data to this table. In order to evaluate the impact of having no validation, let's consider the attributes within the table. What do you think the problems would be if no validation was included in the table? So here's some potential ideas. The voucher requires an expiry date. If there is no validation on expiry date, it's possible for the user to enter a date in the past. We know from the project brief right at the very start that MyTree only sell vouchers in certain categories. So if there's no validation here, it could be that the user inserts a category that doesn't exist. With no validation on price or quantity available, the user could enter an invalid number, potentially negative, or a number that is way above what MyTree would be expecting. In this video, we have looked at the 2021 database task. This has demonstrated some of the things that you may be asked to do in the database task within your coursework. Remember though that the assignment doesn't cover all aspects of the database design and development course. Hopefully now you're more comfortable with what the database task and assignment may look like. I encourage you to go into the SQA past paper website and attempt one of the previous assignments that are available there.